Welcome to Math 1241. We are working on these pre-section videos. These are some general information about the section we're about to cover. In this case, we're covering section 1.3, the limit of a function. And the purpose of these videos is to give you guys an idea of what's going on with this information before your professor actually gives you the great lecture on the topic of section 1.3, the limit of a function. So you already have an idea of what's exactly going on. Now in section 1.3, limit of function, we have a definition here. The definition is this: the limit as x approaches a of f of x equals L. The limit of f of x as x approaches a equals L. That's how you would read this. Basically what this means is this: where is the function value headed as x is on its way to a? So we got a function out here and we're taking the limit as x approaches a. So something is going on out here at a. So if we got this function, we can actually look at it from a graph perspective. Here's f of x right here, and there's this particular a value that we're really not sure what's going on here. So as we take the limit as x approaches a, we get very, very close to a from below, and the limit as x approaches a from above. You get very, very close to a. What's happening to the functional value? Where's this guy going to be occurring at? And the limit value, as you get really, really close to a from below and very, very close to a from above, the functional value, the y coordinate, is getting very, very close to L. Now L is called the limit. So, and as we do this, basically we're doing limit of two different sides. We're doing the limit from below. The limit from below is the limit with a little minus sign behind it. And we're taking the limit as x approaches a from above. And that's a with a little plus on it. So as we get very, very close to a from above, we're going to be plugging in numbers very, very close to a, but not actually plugging in a into this particular function. So a is 2, we'll be plugging in 2.1, 2.01, 2.001, and we want to get very, very close to what the functional value is. So we're looking for patterns on this. And we take the limit as x approaches a from below. So we're going after 2, so we plug in 1.9, 1.99, 1.999. And as we get very, very close, we plug it into our function, we're going to get very, very close to what the functional value is supposed to be. And the full limit exists when the limit from below is going to be equal to the limit from above. I've got to be approaching the same number. So we wrote it up in three different ways here. This is the definition of a full limit. Limit as x approaches a of f of x equals L. Also, we can also look at these one-sided limits. Limit as x approaches a from below, from the negative side of f of x, from the left, from below, from the left. The limit is f of x as x approaches a from the left or below a. And the limit as x approaches a from the right or above a of f of x. And if this number is equal to this number, then that would be the full definition. But here's the whole idea behind these little mini videos. How to do particular problems, getting used to the mathematics behind this stuff. So, now when it comes down to limits, the first rule of limits is this: analyze the function. If you don't have a problem with the function, limits are real easy. For example, limit as x approaches 3 of x squared plus 2x minus 3. This is a polynomial, x squared plus 2x minus 3. This is a quadratic. The domain of a quadratic is all real numbers. Now what we're interested in is this. We're trying to take the limit as x approaches 3. So officially, I'm going to be plugging numbers like 2.9, 2.99, 2.999. Also plugging in numbers like 3.1, 3.01, and 3.001 into my function to figure out what the value is approaching. But here's the real deal. You see this function, x squared plus 2x minus 3? This is a function that has a domain of all real numbers. So I'm going to be approaching very, very close to 3, but since 3 is not a problem in the function, the first rule of limits is this: plug in the number. If you plug in a number and you get a number, that's the answer. So if I want to plug in 3 in this thing, 3 squared plus 2 times 3 minus 3. Well, 3 squared is 9 plus 6 minus 3. Let's see here. 9 plus 6, that's 15. 15 minus 3 is 12. If you plug in a number and get a number, that's your limit. So limits in your basic problems are very simple. If you don't have a problem at the number that you're approaching, you can just go ahead and plug that number into the problem. So take a look at this next example. The limit as x approaches 1 of 5 minus 1 over x. Again, my function is 5 minus 1 over x. And 5 minus 1 over x does have a problem. But the problem is it's 0. I can't divide by 0. So if x is equal to 0, that's going to be a problem here. But look at what I'm trying to take the limit. I'm trying to take the limit as x approaches 1 of 5 minus 1 over x. Officially, what I will be doing to figure out the pattern here is I'll be plugging numbers very close to 1 into this thing. Plug in numbers like 0.9, 0.99, and also plugging in numbers like 1.1 and 1.01 into my function, and to see what I get very, very close to. But since 1 is not a problem with this function, I can plug in 1 and I'll have a domain issue. What you do with the first part of a limit is, first rule of limits is plug in a number. Let's see. This will be 5 minus 1 over 1. 1 over 1 is 1, and 5 minus 1 is 4. So if you plug in a number and you get a number, that is your limit answer. However, these first couple of examples are quite simple. Plug in a number, you get a number, you're done. What happens if we plug in a number and actually have a problem? Let's take a look. Here we go. I'm taking the limit as x approaches 4 of 3x minus 12 divided by x squared minus 16. First rule of limits, plug in a number. Well, plug it in. This will be 3 times 4 minus 12 divided by 4 squared minus 16. Well, let's clean it up. 3 times 4 is 12 minus 12 over 4 squared is 16 minus 16. And if you look at it, you get 0 divided by 0. That's a very important concept. 0 divided by 0. First rule, we're violating a math problem. You can't divide by 0. So officially the answer would be does not exist, right? But we got a problem. It's not just any divided by 0, it's 0 divided by 0. With 0 divided by 0, does it cancel? Like 5 divided by 5 is 1. Negative 2 divided by negative 2 is 1. 0 divided by 0, is it 1? Is it does not exist because we're dividing by 0? Or is the answer 45 or some other kind of number? Honestly, I can't tell. This concept of 0 over 0 is called indeterminate. It's an official mathematical term called indeterminate. We can't tell what's going on here. So, what we're going to do here is this. Anytime you got 0 over 0, there's usually some kind of algebra you can do on this problem, especially if you look at the kind of problem you got. The function is the limit as x approaches 4 of 3x minus 12 divided by x squared minus 16. It's a polynomial divided by a polynomial. With polynomials divided by polynomials, typically when you get 0 over 0, there's some algebra to be done. So I'm going to do the algebra on this thing. Take the limit as x approaches 4 of, let's see here. What kind of algebra can I do to clean up this 3x minus 12 divided by x squared minus 16? First thing I can do is I can factor out a 3. That leaves me with x minus 4. And now I can take x squared minus 16, and that's going to factor by a difference of squares of x plus 4 times x minus 4. Now, clean up the algebra. You will notice that your x minus 4 terms cancel. And notice this is proper technique of doing limits. So I'm continuing writing that word limit as I continue to do the algebra. So this is the limit as x approaches 4 of the remaining part, which is 3 over x plus 4. So I've canceled out the problem with the x minus 4 over x minus 4. And when you plug in the 4, that's your 0 over 0, literally canceling out. And so it gives me a new problem. The limit as x approaches 4 of 3 over x plus 4. Well, again, the first rule of limits is plug in a number. But now I don't have a problem with 4 because I canceled it out. So this would give me 3 over 4 plus 4. And notice, once I plug in the number, I don't write limit anymore. Proper etiquette of mathematics here. And so I'm getting the answer 3 over 8, 3/8. That is my solution. But this is a very special case. Remember this one. When you plug in your number and you get 0 over 0, do algebra. Okay? So let's do another one of these guys. Let's plug it in. Now, officially, let's go back to this problem again. Officially, what I'm really doing here when I'm doing limits is I'm plugging in numbers very close to 4. So I could have taken this original problem and done it the old-fashioned way of doing this incremental approach stuff, like we did with our little picture over here, and plug in numbers very, very close to 4. So I would plug in numbers like 3.9, 3.99, and plug in numbers like 4.1 and 4.01 into this particular function. And as I get very close to 4, you will see the actual numbers get very close to 3/8. But what we're interested in, applying the algebraic techniques to these limit ideas. So here we go. Try this next example. Take the limit as x approaches 3 of x squared minus 3x divided by x squared minus 5x plus 6. First rule of limits, plug in a number. Let's see what we get. This will be 3 squared minus 3 times 3 divided by 3 squared minus 5 times 3 plus 6. Well, 3 squared is 9, so this is 9 minus 9. Divided by 3 squared is 9 minus 15 plus 6. And when you clean it up, 9 minus 9 is 0 over 9 minus 15 is negative 6 plus 6 is 0. What a surprise. It's 0 over 0 again. So it's another one of these indeterminate forms. And with the classic indeterminate 0 over 0, we want to do algebra. So this will be the limit. Now I'm going to redo my algebra on this thing. Limit as x approaches 3. You rewrite the limit word. Now we're going to do algebra. How would you clean up x squared minus 3x? And how would you clean up x squared minus 5x plus 6? Now the whole purpose of 0 over 0 is you're trying to get somebody to cancel. And since it's a polynomial divided by a polynomial, there's some beautiful algebra to be had here. This numerator, I can factor out an x. That leaves me with x times x minus 3. The denominator, I can factor out. I can factor to an anti-full thing here. X squared is x times x. 6, I got a plus 6. So what times what is 6? That adds up to be a negative 5. That's got to be a minus 3 and a minus 2. And you will notice that your x minus 3's cancel. And when you plug in 3, that's that 0 over 0 canceling. So there's a pattern here. So this is the limit as x approaches 3 of x over x minus 2. That's what's left over. And notice I continue to write the word limit. And proper etiquette says I will continue to write the word limit until I actually plug in the number. Well, let's plug in 3. This will be 3 over 3 minus 2. That's 3 divided by 3 minus 2 is 1. So my answer is 3. Now I could do the old plug and chug method on this problem and go back to the original problem. And your teacher will talk more about this, about, well, what you're really doing is plugging in numbers very close to 3, like 2.9 and 2.99 and 3.1 and 3.01 into my function. And you'll figure out when you plug in these numbers using your calculator or whatever, what you'll see that the numbers are going to get very, very close to 3. But this is the algebraic way of doing things. That's what we're after. Okay? But remember, this works with that indeterminate form of 0 over 0. First rule of limits is when you plug in a number, if you get a number, you're done. But here's another example. Now set up the table as x approaches the limit from the left and from the right. An example. Now this is another classic problem. I want you to take the limit as x approaches 0 of 1 minus the cosine of x over x. First rule of limits is plug in a number. Let's see what's going on here. So this will be 1 minus the cosine of 0 divided by 0. Well, the cosine of 0 is 1 from your trig class. This is 1 minus 1 over 0, which is, what a surprise, 0 over 0. So you're going to see a lot of this indeterminate form of 0 over 0. Okay? So here we go. 0 over 0, which means I'm supposed to do algebra. But here's your problem. This is a trigonometric function, 1 minus the cosine of x. And this is a polynomial, x or x to the first power in the denominator. It's not like those other problems that we did where we had polynomials over polynomials. We can do algebra. This is trig. This is just a straight degree 1 polynomial, x. I can't cancel this stuff out. That's the angle on the trig. So there's no canceling to be had here. So when you're in trouble, I got 0 over 0 and I can't figure out what's going on and I don't know what kind of algebra to do, this is where going back to the basic definitions. The first definition is we're going to take the limit as x approaches 0. I'm going to go from the left of 1 minus the cosine of x over x. So this is the limit as x approaches 0 from the left, and here's my function of 1 minus the cosine of x over x. Now here's my x values here. So I want to go to 0 from slightly below 0. Below 0 would be negative 0.1, negative 0.01, and negative 0.001. Get close, get even closer, get even closer. And we're going to 0 from the left. Now, here's where we use our calculator. So I'm going to pull out my calculator here. Now, the reason why I chose this particular problem is this. This is a trig function. And remember in calculus class, with trig functions, we will always be in radian mode unless otherwise specified. Radian is our automatic default. So check your mode on your calculator, because if your calculator is in the wrong mode, you're going to end up getting the wrong answer. We are in radian mode. So here we go. So I'm going to type it in. I'm going to plug in for x, negative 0.1. So this will be parentheses, 1 minus the cosine of negative 0.1, close parentheses for the numerator, divided by parentheses, negative 0.1 for the denominator. And what number do I get? I got a negative 0.04995 something or other. So let me pull it away so the autofocus can hold on. Now I'm going to plug into my function negative 0.01. So I'm going to do this off screen here just to save some time. Here we go. So now I've plugged into my function negative 0.01 for x. So it's going to be 1 minus the cosine of negative 0.01 divided by negative 0.01. What do I get? Negative 0.004999958. So this is negative 0.004999. Okay. Now I'm going to plug into my function my next x. I'm getting very close to 0 from below, from the left. So typing this into my calculator, I end up getting this, and it's great because I'm trying to show you lots of aspects of your calculator and stuff. I get negative 4.99999 e to the negative 4. What does that mean? That means I got to move my decimal place 4 places to the left. So that's 0.000. Moving my decimal 4 places to the left. 499. So, as we take the limit as x approaches 0 from the left of 1 minus the cosine of x over x, what number is this getting close to? Negative 0.04, negative 0.004, negative 0.0004. It's approaching 0. But that's just a one-sided limit from the left. Now we're going to do the limit as x approaches 0 from the right of 1 minus the cosine of x over x. So I'm going to take the limit as x approaches 0 from the right. My function is 1 minus the cosine of x over x. So these will be my x values here. I want to get numbers very close to 0, but this time from the positive side or the right side. So I'm going to plug in positive 0.1, positive 0.01, and positive 0.001 in for x. So plugging in positive 0.1, and I go off screen so you guys can see this to save some time here. Plugging in 0.1 in for x, I end up getting positive 0.04995. Now I'm going to plug in, get a little bit closer to 0 from the positive side. So now I'm going to plug in 0.01 in for x. And I get positive 0.004999. And you're catching a pattern here. So now I'm going to plug in positive 0.001 in for the x's into my function as I'm getting very close. This is the whole idea behind limits. You're getting close, closer, closer, and catching a pattern. if you notice, what a surprise, I get 4.99999 negative 4, which means I'll move my decimal place 4 places to the left, and that's going to give me positive 0.000499. So this is telling me the limit as x approaches 0 from the plus side of 1 minus the cosine of x over x, and positive 0.049, positive 0.0499, positive 0.000499. You notice that we keep adding these zeros into this thing. This thing is going to 0. Now just to remind ourselves, therefore, the full answer, the limit as x approaches 0, full limit as x approaches 0 of 1 minus the cosine of x over x is equal to, well, the limit from the left of 0 is going to 0. The limit as x approaches 0 from the right of your function, 1 minus the cosine of x over x, is going to 0. And since the limit from below is equal to the limit from above, you're actually going towards the same number. And this is the full limit. Both limits have to be equal to each other to get the full limit. The answer is going to 0. And notice I filled in my chart. So again, this is really going for that graphing mode. If you want to graph this function and plug in zeros, getting very, very close. But you'll notice right at 0, the function actually doesn't exist because officially you're not allowed to divide by 0. But as I get very close to 0 from below, from the left, and very close to 0 from the right, my functional value is actually approaching 0. One last little concept here, just to let you guys know. But remember this, we're only doing this algebra with 0 over 0. And if there's classic algebra that you can do, like factoring and stuff and canceling something out. But sometimes the algebra doesn't work with you when you get 0 over 0. Then that's when you want to do what we call the little t-bar. You want to actually do the incremental approach. This is not very algebraic. It's more number crunching in trying to figure out what's going on. But this is the whole idea behind limit. Get very close to a number to see what's going on. But if we did this problem, limit as x approaches 1 of 1 plus 3x divided by 2x minus 2. First rule of limits is plug in a number. If I plug in 1, I get 1 plus 3 times 1 over 2 times 1 minus 2. 3 times 1 is 3, and 3 plus 1 is 4. 2 times 1 is 2, minus 2 is 0. Now this is not indeterminate. This is 4 divided by 0. Indeterminate was up here with like 0 divided by 0. With 4 divided by 0, remember in mathematics, rule of thumb is you can't divide by 0. So when you ever have a number other than 0 divided by 0, we would say the answer is D and E. That's my way of talking about does not exist, otherwise known as no solution. D and E stands for does not exist. You can't have a number divided by 0. But this interesting 0 divided by 0, well, that's different. That's an indeterminate form. We can't tell if it cancels or if I'm having a problem with dividing by 0. That's when you either want to do the incremental step approach, which is what we're doing here, or you want to go back, and if it's got the same kind of function like a polynomial over a polynomial where you can actually do some algebra, do the algebra, clean it up, because 0 over 0, something should cancel if it's a similar type of problem in the numerator as well as the denominator. So this is the whole idea to get you guys started. Now your teacher, your professor is going to go into this particular section and talk about more ideas behind this limit of a function. What it is, what you're doing, and why you're doing it. This is just a kind of a pre-section video to kind of give you guys an idea of what's going on and what you can expect from this particular material. So study hard, and we'll see you on the next video.